All right, so you've just turned in your second to last homework assignment, which that's good. The project is due a week from today, so time has really passed quickly. I remember when I introduced the project, it seemed like the date would never arrive, but here now it's just a week away. I've been getting some good questions from people about things like the effective tax rate, things like expenses and how to cite that. I don't have any particular preference in the project in terms of what citation methodology you use, and so whether it's APA, MLA, I honestly don't have any preference as long as you're consistent and as long as it's clear that what you've used as the source for information. So the project's due a week from today. We're going to be moving into Chapter 16 now, Depreciation. We actually have quite a variety of topics that we're going to be covering in the remaining weeks of the course. So here we are today in class number 36, talking about depreciation, and you've turned in homework 12. So the next kind of deliverables for you is the project a week from today, and then the Wednesday after spring break, you'll have homework 13. And so between now, spring break, no, did I say spring break? It's a break, but it's Thanksgiving break, yeah. So we've got a couple of class periods of depreciation. Then we're going to be talking about risk and modeling uncertainty. And then we'll do some tax-related things. And the last two class periods, this will actually be new material that I've added just this semester because Marshall put in a couple of additional lectures into the semester. So based on some feedback I'd received in previous course evaluations, people said that they were interested to learn more about personal finances and investing, and so that's what we'll finish up the semester with. And then our final exam is on Friday the 13th. So if that's not the best omen, right? Friday the 13th is your exam. And the exam schedule is posted on the registrar's website if you're curious to double check how that works. So we're going to be meeting on Friday the 13th because our class is at 12 o'clock on Monday, Wednesday, Friday. So the time that they've reserved for us is from 10:15 until 12:15 on Friday. That'll be 120 minutes. Ordinarily, we only have 50 minutes for exams. So that gives me a lot more time to rake you over the coals. Or you could think of it in terms of it gives you more of an opportunity to show how much you've learned. Because, I mean, honestly and truly, we've covered so much ground that if there's only 3 questions, like 3 problem-solving questions on an exam, that may not be a representative sample of what you know. So my intention is to try to make the questions a little bit smaller in size for the final and then have, relatively speaking, more of them. So instead of 3 big questions in 50 minutes, we're going to have 120 minutes, and so we may have 10 smaller questions. I don't know. I haven't written it yet, but that's just an idea I've been toying around with, is I want to have variety. And so there's going to be added emphasis on the material since the second midterm exam. So if we go back to the list of topics, we had our midterm exam at class number 30. So there's going to be a disproportionately high number of points available on this material that you haven't been tested on yet. But there will also be, since it's a comprehensive exam, there will also be questions from all the way back to the beginning part of the semester. So you need to be prepared for everything, but there's going to be maybe more points available on this more recent material.
Well, we still don't have for 1C of notes for the final one.
No, you'll be able to bring 3 pages of notes for the final exam. The course covers, I think, 3 main parts, and so I think 3 pages front and back ought to be more than enough to confuse yourself. I think that honestly, sometimes people draw a little bit of a sense of misplaced comfort in having an equation sheet where they think, everything I need to know is there. But, I mean, it's impossible to capture everything, so I don't know. One time I gave bonus points to students who took the final with no equation sheet, but what I found out is that they didn't need the bonus points. That, like, if you had the confidence to take the final without a provided equation sheet, that meant that you already knew everything well enough that the bonus points were meaningless. So I stopped doing that. But if you want to take the challenge, you just show up and just use only the provided equation sheet mainly. All right, we're going to be talking about depreciation today. And I think it's something everybody already understands instinctively, that when you buy things and they wear out, that they lose value over time. And I think you probably also have heard the idea that depreciation isn't necessarily linear, that things lose value really quick earlier on. Sometimes people say as soon as you drive a new car off the lot, it immediately loses 10% of its value. And I don't know if that's true or not, but the point is that, like, buying a new car is different from buying a used car. Some people just don't want anything that's been used before. They only want something that's new. And so because of that, even if it's only got 5 miles on it and it was only owned for a single day, just the idea that somebody else owned it first is off-putting to some people, and it would have maybe less demand for that item. But technically speaking, depreciation is an accounting method that's used to allocate the cost of a tangible or physical asset over its useful life. So what that sounds like to me is that sounds like find A given P. Because the time value of money formulas are saying if we've got a lump sum expense, we can annualize it. But find A given P is a little bit crude for what really happens in the real world, because, as we've just discussed, depreciation isn't linear. Find A given P would suggest that it's the same value of reduction in price, or reduction in the same amount of a reduction in value in all the years of its useful life. And it may not be equal like that. The arrows of depreciation may not be the same height. Maybe they are, maybe they're not. So this is just one definition of depreciation from Investopedia. Here's another illustration of what depreciation is: a decline in an asset's value over time. Why do we care about its decline in the asset value? For accounting purposes. So this is saying here an accounting method. So the point I want to emphasize is that, of course, it is relevant that the equipment is getting beat up if it doesn't perform as well. Like, that's relevant for a real world reason. If the equipment is becoming less useful somehow, then that may affect our operations. But completely separate from that, there are accounting considerations, mainly dealing with taxes, where even if the item is exactly as good in the future as it was when you first bought it, we still want to somehow allocate a reduction in value over time because of what it does for taxes. And so here, this is showing the nonlinear curve of an item losing value really quickly up front, and then the value decline starts to stabilize. And so maybe the steepest portion of the decline in the asset's value is when it's still under warranty. Because once it's out of warranty, then its value mainly is related to the underlying condition of the item, not so much how much warranty is left. But we'll talk about differences in shapes of curves with depreciation. But let's go over some terminology. Depreciation is the decrease in value with the passage of time and use. And as I indicated earlier, taxes are a key motivator for keeping track of depreciation, because it's a deduction against your income. So if you've got equipment that's becoming less valuable, what you can do is you can use that to offset your profits, and then you pay less taxes. So you had to buy equipment to earn money. If you've got some sort of a business, most businesses have some sort of equipment that they're using, whether it's computers or machinery or vehicles. Most businesses have some sort of an asset which is depreciable, and the amount of depreciation that occurs in a year can be used to offset the tax that's due. So in order to do calculations of how much depreciation occurred, we have to have a cost basis, which is the starting point value of the item. And so it's more than just the purchase price. It's the purchase price plus whatever taxes you paid, and then also the things that you had to spend to get it in service. So that may be like the transportation costs or accessories that were required for the item or operator training, the things that were used to get it in service. Now the book value is just how much the asset is worth at any particular time from an accounting basis. Now I want to emphasize this again, that the book value may be different from its market value. Market value is how much people would pay if you listed it on a secondary market. Like if you were going to sell a car, its market value could be different from how much the book value is. The book value is just this hypothetical accounting principle that says we know the initial cost basis of the item, and there's been a certain amount of depreciation up until now, and the difference between the two is the book value. So book value may not be the same as market value. But we still like to calculate the book value over time because it tells us how much depreciation remains in an item. And it allows us to estimate like the future deductions we may be able to take in taxes for further depreciation of the asset. So any questions so far about depreciation? Not everything can be depreciated. So there's some criteria. You have to be using it for business. So the thing, your clothing that you wear, that's not depreciable because it's not, well, unless you are maybe like a model or something or buying clothes for the business of, whatever the item is, it has to be used in business to produce income. It has to last longer than a year. So like food wouldn't be depreciable, or printer paper wouldn't be depreciable because that's a consumable item. It has to be a tangible asset, meaning like a physical item that wears out, decays, gets used up, becomes obsolete. So it's something that has to wear out over time. And it's not possible to depreciate the items that you are selling. So it can't be inventory. And businesses are always looking for ways to maximize the amount of depreciation they're getting, and also they want to maximize the things that are counted as depreciable. So you have to think in terms of, like, depreciation represents a reduction in value, and it represents wear and tear, and it represents decay, but businesses want depreciation. Because remember that depreciation is book value related. It's this hypothetical thing. They don't want their equipment to wear out, but they want the depreciation, which is an indirect representation of the decay of their equipment. And they want it because it reduces the income tax they have to pay. So these are all really important concepts. And on the final exam, we'll definitely still have some more concept questions. And I think depreciation is a topic that is ripe for questions related to conceptual understanding. So there's a couple of different ways to calculate how much depreciation occurs in a given year. And the simplest of them is called straight line depreciation. And straight line depreciation is called straight line because unlike that figure we saw a few moments ago, this is not straight line. Straight line depreciation assumes that every year has the same depreciation amount. So the depreciation amount is equal every year, and it may terminate in the final year at either a salvage value or it could go to zero. It has the capacity to account for either in straight line depreciation. The next most complicated system is declining balance. And declining balance says that rather than having an equal dollar value in depreciation every year, it's an equal percentage of the item's value every year. And so a certain fraction of its initial value is lost with the passage of time. And it can also account for salvage value in declining balance depreciation. Both of these have largely been replaced. The federal tax system is built on these, but you don't have to calculate them directly in the same way that you used to. It's good to know about them because these two methods are what's going on in the background for the Modified Accelerated Cost Recovery System, MACRS, Modified Accelerated Cost Recovery System. And so it's sometimes also called the General Depreciation System. And the way it works is it starts off as straight line depreciation for the first couple of years of the item's depreciation, and then it switches to, oh, actually, no. It starts off as declining balance, and then it switches to straight line. So it starts off steep, and then it flattens out the curve, and it goes to zero. So the nice thing about this MACRS system is you don't have to do the calculations in the same way, where they just provide tables for you, pre-formatted depreciation tables, and then based on the type of equipment and how it's classified, you just use the pre-existing tables to calculate the depreciation. And so you wouldn't have to set it up manually like we will for straight line and declining balance. All right, so let me show you an example of the formulas used for straight line depreciation. It's a linear decrease in value every year, and the depreciation in a given year is the book value minus the salvage value divided by the number of years in the recovery period. And notice N here, it doesn't say useful life, it says recovery period. Because some equipment, you can depreciate it over a shorter amount of time than its expected useful life. So, for instance, an automobile, you might be allowed legally to depreciate it over a 7-year period, whereas the automobile itself might last for 15 years. So N isn't necessarily the useful life, it's the recovery period. And so if you've got this D, which means the amount of depreciation in a given year, the book value in a certain year, the book value in a certain year would be the cost basis minus the number of years of depreciation that have occurred multiplied by the depreciation per year. So this is how you'd find out the book value in any given year, is with this formula. And in straight line depreciation, then the depreciation amount is constant every year. So here's an illustration. Let's say that we had an argon gas processor that cost $20,000, and after 5 years it's got a salvage value of $5,000. So here's a graph that's just showing it goes from 20,000 down to 5,000 in a 5-year period, and we're assuming that it's a linear trend. So what that means is that the depreciation per year is $3,000 because the incremental change in value is 15,000 if we've got 20,000 minus 5. So the reduction in book value in 5 years is 15,000, and we're dividing it by the 5-year depreciation period. So that means every year it's 3,000 that's being depreciated. So then the book value in year 3 would be the initial cost basis of 20,000 minus 3 years of $3,000 per year. So in year 3, what that means is that there's $11,000 in book value remaining. One of the nice things that landlords are able to do is they're able to buy a house and they can depreciate the house. So the rent that you pay in a lot of cases isn't taxable because the landlord who bought the house you're living in is depreciating the home, and the amount of the depreciation oftentimes will be larger than the rent that they're receiving. So it's kind of a hack that landlords like to take advantage of, is making their rental income tax-free by depreciating the house, and then also the cost of the improvements that they make when they refurbish it reduces their taxable income as well. I was tempted to try and become a landlord, but it just seems like so much hassle. So much hassle. Didn't have the stomach for it. All right, let me hand you the in-class exercise for today. We're going to start off with this straight line depreciation. All right, so this is just to get some practice with straight line depreciation. I would suggest you do this one by hand. The second one on the back side of the paper, we'll do that one either by Excel or by hand. But I think this one, it's best to just crunch the numbers using your calculator and solve it by hand. Okay, so the first part of it, in part A, it's asking for the total amount of depreciation in year 3. That means that we have to find out the individual depreciation for each piece of equipment. So for the loader, the mixer, the crusher, and then in that first year, all 3 of them have depreciation available, and if we add it together, it's over $21,000. Part B is asking us about the book value at the end of year 3. So book value, remember, means the cost basis minus however much depreciation there's been up until that point. So the end of the 3rd year, then we've got 3 years of depreciation for each of the loader, mixer, and crusher. So we start off with their book value and then subtract out 3 years of depreciation and add together the book value of all 3 items, and it's $121,000 in book value at the end of the 3rd year. And then at the end of the 5th year, the mixer has no book value left because the mixer, remember, depreciated in 4 years and it went to a salvage value of 0. So it no longer has any book value at the end of year 5, but the loader and crusher do, and combining their book value together, it's around $84,000. And then the last part here about the amount of depreciation in year 8, there's just only the crusher that still has any depreciation remaining in year 8. And it's the same amount every year, $9,955.56 for the crusher. So pretty simple accounting, just maybe a little bit time consuming and tedious, but we could speed things up if we use Excel, and we will for the next kind of depreciation, for declining balance. Declining balance, what you do is you have a certain percentage that the depreciation is based on. And sometimes that percentage will just be stated directly. Other times you'll have to calculate the percentage based on what is the depreciation period and the known salvage value. So the way that the declining balance works is that once you know this percentage of depreciation that occurs each year, lowercase d, the depreciation factor, you'd multiply that by the book value in the previous year to find out the depreciation for this year. So T is whatever year it is. So if T is the 3rd year, the 3rd year's depreciation would be based on the 2nd year's book value. So you kind of have to keep a running total of the previous year's book value in order to know this year's depreciation. And this factor D can either be given by a certain percentage being described. And the percentage, the way that works is they'd say like 150% depreciation. What that means is that the slope of the line is 1.5 times steeper than if it was straight line depreciation. So the percentage is just basically talking about the rate of depreciation compared to straight line. Or D can be defined by knowing a certain salvage value relative to the initial book value and the recovery period N. So let me illustrate the way that all of that works and how we can use it to calculate the book year, the book value for a certain year. If we had a truck that cost $80,000 as its first cost, and let's just assume that that's the first cost all in, that that's the cost of acquisition, training, shipping, tax, everything. And it's got a depreciation period of 10 years. So here it says lifespan. Let's assume that what that really means is the depreciation period is 10 years. So let's describe the depreciation and the book value over that 10-year period based on 150% depreciation. So this first one, that will 150% will define lowercase d. And then in the second part, we're going to have to calculate d by knowing what is the known salvage value. And I'll do this on Excel just to illustrate the calculation process. All right, so for part A, our percentage that's been defined is 150. The N in years is 10. B, the cost basis, initial acquisition cost is 80,000. The salvage value, what was the salvage value? Well, it's not actually known in the first part, in part A. It's not given explicitly. We'll calculate it later on. D, lowercase d, is defined as the percentage that's given. So 150 divided by 100 times n. So that formula was on the previous slide. Let me show you the formula I've just used there. It's this one for part A. That's how we calculate D. All right, so now what we want to have is year, the depreciation amount, and then the book value for every year. So starting at time 0, we know that the book value is the initial acquisition cost. And then we're going to go down through 10 years and try to determine how much depreciation there is each year. And the first year's depreciation is going to be 15% of the previous book value. So the depreciation amount is the depreciation factor times the previous year's book value. So I'm anchoring the reference to 0.15, but I'm not anchoring the reference to the book value, because as the book value decreases, then the depreciation amount will also decrease with each subsequent year. So the book value at the end of the first year is the previous year's book value minus the amount of depreciation that happened this year. All right, so then next year's depreciation is going to be 15% of the previous year's book value. So you'll notice that the depreciation amount went from 12,000, which was 15% of 80,000. And now for the second year, the depreciation amount is 10,200, which is 15% of 68,000. So then I can find out how much book value there is after that amount of depreciation, and I can actually carry this all the way through the 10-year sequence and see what is the depreciation over time. Let me just format this as currency. All right. So in the end, if it's 15% depreciation every year, then the terminal salvage value would be calculated as $15,749.95. But you can just see that this is not a straight line, that the amount of depreciation is going down every year because it's always 15% of the previous year's book value. Okay, so that's how we would do this according to the first technique for calculating D, which is defined by a percentage. The next one is defined by a salvage value. And so in part B, if we know the salvage value is 10,000, let's do here for part B, instead of percentage, we're still going to have N is 10. We're still going to have B as 80,000. This time we do know salvage. It is 10,000. And so we're going to have to calculate D using this formula for part B. So D is 1 minus S divided by B to the power of 1 divided by N. So in the previous one, we just knew it was 15% depreciation every year. What this is doing is it's calculating what percent depreciation is needed every year in order to achieve the known salvage value of 10,000. And so it's going to need to have an 18.7% reduction in value every year in order to hit that target of $10,000 at the end of the time sequence. And so we still have 10 years of depreciation in part B of this example. And the book value still starts at 80,000. And the process is the same. It's the depreciation amount is this factor, which I'll anchor by pressing F4, multiplied by the previous year's book value. So how much it depreciates in the first year is this 18.7% of the previous year's book value, and then the book value at the end of the first year is the previous year's book value minus the depreciation amount for this year. And then we just carry that through the entire sequence of 10 years. And we see it does hit that 10,000 target. It's supposed to, at the end of 10,000, at the end of 10 years, get to a salvage value of 10,000. And so now we know the depreciation amount and the book value for every year according to declining balance. So for you, on part 2 of the in-class exercise, the back side of the paper, I think we've got enough time to tackle this one. Let's say it's a roadway paving machine that's going to last for 8 years. So using the same technique that I just illustrated, calculate what is the depreciation in book value using 150% declining balance or with an estimated salvage value of 87,000.
Such a big number. That's right. No, this is the one. This is the one. Yeah. Oh, because you're multiplying by the years, not by the. So you multiply this by that. But then you have to lock your D. salvage value is 87,000, about 1,000, right? And they would be used differently, yeah. There you go, that's right. And so then, no, that's not right.
What is it? D. It is percentage divided by 100 times n. Oh, yeah, in the denominator.
There you go.
Okay, so it's 12:49. We've only got 1 minute left. If you don't finish this one up, the numbers are going to be in the video. You can look at them now, but it's also in YouTube along with all of the calculations. We're going to continue talking about depreciation in class on Friday. And if you've got any questions about the project, feel free to stop by. I'd be happy to help you out. So I'll see you on Friday.